This is Math 70, Section 5.6, Scientific Notation. This is the last section in Chapter 5. A test will be available very soon. It is regarding scientific notation. I tried to print the notes that I emailed you guys, but unfortunately my printer ran out of ink and I cannot go out and get more ink, so I just wrote them out for you. It's a little easier than toggling the book back and forth. But anyways, we use scientific notation because there's numbers that are extremely large, like let's say from the number of people in the world, or how far you are from here to the moon. So we take these very large number or very small numbers, like for example these very small numbers here, these are small, that's a large number, and we have to convert them into scientific notation. Right now these numbers are in example 1. I have 6 problems here I'm going to show you how to do. They're in decimal notation. To put them in scientific notation, you have to understand that there is a decimal in every number. And sometimes you'll see it, like in example 2, you'll see the decimal, but in example 1, the decimal is understood to be right after the 3. Okay, so we should all know that. So now, to put a number in scientific notation consists of 2 parts. You have a number, okay, we'll call it x, and this number has to be between 1 and 10. It has to be greater than 1, but less than 10. So it's between 1 and 10. So we'll say x is less than 10, but greater than 1. Okay? And then you're going to have, it's going to be times and 10 to 8 power. Okay? So it consists of 2 parts, a number and then times 10 to a number. Okay, so what you're going to do, you have to move this decimal to a place that's going to give you that number between 1 and 10. The only place it could go is between the 5 and the 2. So you're going to move this 1, 2, 3 places to the left and turn your lead number into 5.2. If you want to write 83, that's fine. 5.283 times 10. Now, since you moved it 3 places to the left, this is going to be times 10 to the 3rd power. Okay? Now, for this one, you want to move this decimal between the 5 and the 4. So it's 2 places. This would be 5.4 times 10. Since you're going to the right, it's going to be -2 power. So if you're going to the left, it's a positive power. If you're going to the right, it's a negative. So I have a few more examples to show you. So for this one, you're going to move it between 1, 2, 3, 4, between the 1 and the 0. So it's 1.0302 times 10 to the 1, 2, 3, 4 power. The next example, you're going to go 1, 2, 3, 4, 5. So this is 4.59 times 10 to the -5 power. Next one, 1, 2, 3, 4, 5, 6, 7. 8.5 times 10 to the -7. 1, 2, 3, 4, 5, 6, 7. And then 5.432 times 10 to the 1, 2, 3, 4, 5, 6. Okay? Now, how do you go from scientific notation, I spelled that wrong, scientific notation to decimal notation? So we want to write it as a decimal. So these ones are easy. If the power is positive, think of moving this decimal towards the positive side. So you're going to move it right, and then you're going to add 3 zeros. So, I'm sorry, not add 3 zeros, add 2 zeros, because you're moving this 1, and then you're going to add 2 more zeros. So it's 2, 3, and then add 2 zeros, because you've moved this over 1, and then you have to insert 2 more zeros to compensate for that. Now this one, -5, you're going to move it 5 places to the left. So all this looks like it's opposite. So if it's a big number, you're going to make your exponent positive. If it's a small number, it's a negative exponent. And then these ones are the opposite. If it's a negative exponent, you're going to the left. If it's positive, you're going to the right. Hopefully you can understand that. So for 4.57, you're going to move it 5 places to the left. You're going to go to the left. So 1, and then add 4 zeros. So 0.0000457. Okay? Now, there are some operations you can multiply and divide with scientific notation. This is how you do it. These are, so think of this as, would be like multiplying 3 times 10 to the second power is 300, and then this is times 2, 5, 1, 2, 3, 4. It's like multiplying those two numbers together, okay? So this is how you do it with scientific notation. You multiply the two lead numbers. So 3 times 2.5, and you're going to multiply these two, 10 to the second times 10 to the fifth. Now, you already learned in the last sections how to multiply when bases are the same. You add the exponents. So keep this as 10, and then add these two, you get 10 to the 7th. And then just multiply these two, and you get 7.5. So your answer is 7.5 times 10 to the 7th. So let's do another one. And you want to make sure that this number is between 1 and 10, and it is, because there's going to be an example where it's not going to be. So example number 6a is right over here. So we have 4 times 10 to the -2 times 6 times 10 to the 8th. So you're going to multiply 6 times 4, you get 24. And then to multiply these two, you keep it as 10, and you're going to add these two. -2 plus 8 is 6. Now there's a problem. This number is not between 1 and 10. So you're going to write 24 as 2.4 times 10 to the first power times 10 to the 6th. And now 2.4, you're going to add these exponents times 10 to the 7th power. 1 plus 6 is 7. Now that is the correct answer. This lead number has to be between 1 and 10. Okay, next one. We have to multiply 3.2 times 4.8. So let's do 3.2 times 4.8. Good review. 8 times 2 is 16, 24, 25. 4 times 2 is 8, and 12. So 6, 13, 5. So this would be 1, actually, and we have to move the decimal 2 places in. So 15.36 times 10, we're going to add these, -7. So now I need to convert this to 1.536 times 10 to the first power, and then times 10 to the -7. And now these bases are the same, so we're going to add these exponents. 1.536 times 10 to the -6 power. Last two, how do you divide? Well, with division, you're going to divide the two lead numbers. 6 divided by 2 is 3. And we learned, what do you do when bases are the same and you're dividing? You keep the base the same, and you're going to subtract these. So 6 minus 2 is 4. And this is good because 3 is between 1 and 10. Now this one right here, you're going to divide 2.4 divided by 3, which is 0.8. And now we're going to subtract 4 minus negative 2 is 6. Now, unfortunately, that number is not between 1 and 10, so we have to move this over 1. So you're going to write this as 8 times 10 to the negative 1 power times 10 to the 6, and then add these two exponents, and you get 5. And that concludes section 5.6.